Data is the key to many important management decisions. Before we jump into the more advanced statistical analysis tools, we need to talk about the basics of data. As we all know, process improvement needs it to be measurable by data collection, which is critical for any improvisation. Now let's come to the types of data. First is discrete data. It is any data that is limited to a specific range of data and cannot be more precise. It usually involves whole integers or can often simply be pass, fail, or good-bad assessments, whereas continuous data is any data that can be measured across a wide scale and can be reduced to final results. Now, it is also critical to understand the conversion system. Continuous data tend to be more precise due to decimal places but need to be converted into discrete data, as continuous data contains more information than discrete data. Hence, during conversion to discrete data, there is loss of information. Discrete data cannot be converted to continuous, as instead of measuring how much deviation from a standard exists, the user may choose to retain the discrete data as it is easier to use. Measurement. Process improvement needs it to be measurable by data collection, which is critical for any improvisation. A measurement is assigned numerical value to something, usually continuous elements. Measurement is a mapping from an empirical system to a selected numerical system. The four measurement scales employed are nominal, ordinal, interval, and ratio, which are discussed below. Control chart. Control charts can either be unvariate when they monitor a single CTQ characteristic of a product or service, or to be multivariate when they monitor more than the CTQ. A typical control chart plots sample statistics and is made up of minimum 4 lines of a vertical line to measure the levels of samples mean, the two outmost horizontal lines for the UCL and the LCL, and the center line which represents the mean of the process. If all the points plot between the UCL and LCL in a random manner, the process is considered to be in control, which means that the variations are random but are not outside the control limits. Thus, the process trends can be predicted because the variations are strictly due to common causes. As per the Western electric rules, a process is said to be out of control if one of the following occur: the P chart, the NP chart, the C chart, and the U chart. The equations or formulas for the P chart, NP chart, C chart, and U chart are given in the slide. Variable control charts. Control charts monitor not only the means of sample for CTQ characteristics, but also the variability of those characteristics. These control charts are used more often and they are more efficient in providing feedback about the process performance. The principle underlying the building of the control charts for variable is the same as that of the attribute control charts. The types of variable control charts are X chart and R charts, standard error based X chart, mean range based X chart, and R chart. The equations and formulas for these charts are given in the slide. Process capability is a predictable pattern of statistically stable behavior where the chance causes of variation are compared to the engineering specifications. A capable process is a process whose spread on the bell-shaped curve is narrower than the tolerance range. Process capability study attempts to quantify whether a process can consistently meet the standards set by internal or external customers. Measuring capability. It can be challenging because it is by definition a point estimate. Every process has unpredictable instability, which creates an inherent risk of estimate errors. Since there is no confidence interval related for mean and standard deviation, there is no confidence interval for capability. Therefore, risk cannot be quantified. The image clearly shows that the objective of a process capability study is to establish a state of control over the manufacturing process and then maintaining that state of control through the time. The steps of process capability studies are given in the slide. Process performance versus specification. The performance metric indices establish a controlled process and then maintain that process over time. Process limits are the voice of the process based on the variation of product produced. Process performance metric is a measure of an organization's activities and performance and include metrics like percentage defective, which is defined as the total number of defective parts divided by total number of parts multiplied by 100. Process capability indices include CP and CPK, who identify the current state of the process and provide statistical evidence for comparing after adjustment result to the starting point. You can look at the equation given in the slide to measure CP and CPK. CP measures the ratio between the specification tolerance and process spread. CPK measures the absolute distance of the mean to the nearest specification limit. CPM, also referred to as Taguchi index, it is more accurate and reliable than the other indices. It focuses on reducing the variation from a target value T. The most used process performance indices are PP, PPK and CPM, which depicts the present status of process and also act as an important tool for improvement of the process. PP measures the ratio between the specification tolerance and process spread, while PPK measures the absolute distance of the mean to the nearest specification limit.